Hello and welcome to the Daily Space for today, April 19th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. We have, oh my God, what a news day. There are so many stories that it's starting to make me think I need to get up earlier in the morning to prepare for these shows to go off on time. After a winter of science drought, all the publications are coming out, and we have news coming to us from the Earth, from the solar system, and from beyond. But before we get to what's new, I want to talk about what's coming up. We have been producing the 365 Days of Astronomy podcast for 10 years, and I think it's time to celebrate. On April 27th, we are going to be hosting a 10-hour live stream right here on twitch.tv, and you are invited to join us. All the times are right there. I am going to be doing hosting. We will have Annie Wilson present to help with production, and we are working to bring in as many of the podcasters who have contributed over the past decade as we possibly can. So tune in to see a lot of faces and mark it on your calendars and prepare to make us part of your day. Now, with that announcement out of the way, I am going to continue on to today's science. Our first big news story of the day comes to us, well, with a side dish of, oh God, that's horrible. This is a story of the Larsen Sea ice shelf. For those of you who don't know where this is located, it is at the tip of Antarctica. This is one of the largest ice shelves that still remain. It is that light blue region under here, underneath where it says melt location. Let's see. Oh, still learning to green screen. Right there, that light blue. That is the Larsen Sea ice shelf. Now, in recent images of this ice shelf, people have been noting a large number of beautiful pale blue regions. This is real color. And sadly, all of that blue represents where liquid water is building up on the top of the shelf. Now, this is bad for a number of reasons. Now, what is happening is warm air is blowing over the mountains of Antarctica and dropping over the mountains to warm up the ice here on Larsen Sea ice shelf. And what that warm air is doing is, well, it's melting the glacier. And this buildup of water is particularly bad for two different reasons. The first is the meltwater can seep down into the cracks, go down underneath the glacier, essentially act as a lubricant, increasing the rate at which movement occurs, increasing the rate at which fragmentation occurs, deepening pits, all the things that you might have seen if you live in a snowy climate when things start to melt, but on a much bigger scale. Now, the other reason this is bad is when you have this kind of surface meltwater, when new snow falls and it hits that meltwater, which takes longer to freeze than, well, water in the air that's just a single snowflake falling down. When snow falls onto that meltwater, it gets melted to be more meltwater. And so you end up with what normally would be snowfall helping to rebuild that ice shelf is instead just adding to the problem. This is leading to it's leading to increased concerns of more large sections of Larsen Sea ice shelf crumbling off that Antarctic peninsula and causing sea levels to rise. This is one of the largest, ice shelves with the potential to do this. And when this ice shelf goes, as it has started to do, there was a massive iceberg that came off back in 2017. When the rest of this ice shelf goes, we will see measurable sea level rise across the world. So yeah, that's a thing. And just when you thought you might be safe in California, We also have news coming from there that you are shaking more than you might have known. For the past several years, geophysicists, geologists have been deploying new and more sensitive networks of seismographs that have allowed them to realize that some level of earthquake is occurring in California roughly every 3 minutes. I'm going to zoom in on the San Jacinto fault line, and each dot represents a separate earthquake that was detected. And by looking at the epicenters of all of these different earthquakes, they're able to map out the individual, basically, details in the fault lines. Now, what's happening here on the biggest scale is we have two plates that are trying to move relative to one another. And thank you for the sub, Wayne Johnson. Thank you so much. I will give the dogs treats of thanks and cuteness at the end of the main episode. So what's happening here is as these two plates move, it's a jagged process, and there's various faults within the two plates. So it's much more like this kind of a situation where maybe this part will give, then this part will give. And by measuring every single little earthquake and its center, they're able to get these high fidelity, highly detailed maps of the faults, and they're finding faults in places that we hadn't fully known about. They are realizing where the energy is getting stored, and it's hoped that eventually this will allow us to predict better when earthquakes are going to go. By measuring all the little tiny earthquakes, all these things that are going off every 3 minutes and are generally not noticed by anyone, by measuring with technology things that humans don't notice, we may be able to finally start seeing a pattern of behavior along a fault line when a big earthquake is about to happen. It's all about the pattern matching. At a certain point, computers are going to figure this out and see patterns that the human brain hasn't been able to pick out yet. And in the interim, it's not like the Earth is behaving any different than it was before. This has probably been going on for thousands of years. It's just a little troubling to know. And this goes to show us that the human brain is emotional and not logical, because this is a result that left me feeling queasy, even though I don't live in California and nothing has actually changed, except we have better data that will hopefully lead to better predictions. Thus goes the human brain. Continuing on in what is turning out to be a whole lot of Earth science, but Earth is a planet, and the physics that applies here does apply on all the other worlds, give or take values for gravity and atmospheric pressure. In story coming to us from Northern Europe, we have a tale of how the lightning strikes twice. Now, you may have heard lightning doesn't hit the same thing twice, and if you heard that, it's just wrong. Lightning likes to hit tall objects. It will hit them again and again. And now we also know lightning will follow the exact same path through a cloud twice. There is a massive telescope array called LOFAR. It spans more than 3,000 square kilometers. And this long frequency, high fidelity, I'm just apparently using the word fidelity a lot today. This system allowed scientists who normally use this to study distant objects in the universe to instead make detailed observations of lightning storms occurring over the telescope array. These are radio dishes, and what they captured is pretty amazing. Here is a YouTube video. And what we're seeing is the lightning strikes and the buildup of electricity, in this case, static electricity within the cloud. And all of these different lightning strikes, you can see that they're essentially building up channels through the cloud and then moving along those channels. It's just beautiful. I'm going to play it again. What they were able to discern and what we would be able to see if I had the ability to zoom in sufficiently on this YouTube video, which I don't, is the lightning is creating a primary channel through the cloud, but also building up pockets of potential energy, static electricity, in channels that are hundreds of meters long, meters wide. And in those channels through the cloud, multiple discharges can occur. The way my science fiction loving brain translated it is it's like charging up a phaser, where when it's charged up, you can fire it more than once, but it takes a bit of time to charge up. So we're seeing the clouds charge up, store their potential, and firing it over and over again along the existing channels. Now, lightning is something that should best be observed from inside your house, inside your car, or apparently using radio telescopes. And I advise all of you to enjoy your next lightning storm with a little bit more understanding of exactly what is going on in those clouds. Now, our next story takes us a little bit further from home, and this is a story of just what happens when our moon gets hit with meteorites. Back in January, we brought you a story of how during the January 2021 lunar eclipse, many people were able to observe, even with their eyes, the strike of a meteor on the moon. Meteor strikes like this are, we now think, fairly common. And looking at data that was collected between November 2013 and April 2014 by the LADEE spacecraft, space scientists have now been able to figure out that when these meteor strikes occur, they actually liberate water molecules from the lunar soil. Essentially, you have compact soil. Part of that soil mix is water molecules, just like your own backyard soil has water mixed in with the soil. And when a space rock comes in and hits that soil, it springs all of the material up into the air. And LADEE was able to measure water molecules into it actually does exist and is extraordinarily thin lunar atmosphere. Air is probably too strong of a word, but there is a barely there but measurable lunar atmosphere that gets enriched every time a rock hits the moon. And this makes it clear that, yes, there is water. No, there's not a lot of it. But hey, you can liberate it from the rocks. And this also helps us understand how water is able to migrate around the moon. We know that it tends to build up primarily in the northern and southern latitudes, those areas that get a lot less sunlight. But it comes in and is delivered by some meteors all over the planet. And we also see it migrate from day to night. Well, these kinds of events help liberate it from the surface and allow it to move around. So, hey, here's to the liberation of water on the moon. Now, in news of the weird, the other night on Twitter, I caught a bunch of people basically tweeting, so we're not going to discuss the alien rock that hit the Earth? And that seemed to be a very weird thing for people to be tweeting because, indeed, I knew of nobody discussing this. And in fact, I still haven't found a press release. This paper was quietly released into the wild. It is a paper that, as so many papers of the odd do, includes Abraham Loeb of Harvard Smithsonian Center for Astrophysics, working in this case with Amir Siraj. This paper talks about how, inspired by the visitation of Oumuamua, an asteroid that is on a intergalactic journey through not just our solar system, but our galaxy, they were inspired to go through historic records of meteor strikes and see if they could find any incoming asteroids that had orbits consistent with those objects coming in from somewhere other than here. And the answer was yes. Yes, there are. They were able to identify a almost 1 meter wide object that disintegrated in the Earth's atmosphere back in January 2014. Now, before that object disintegrated in our atmosphere, it was measured to have a orbit that took it around the sun at a brisk 60 kilometers per second. At that speed, it was clear this object was not one that was orbiting the sun. It was just passing through our solar system. Now, since they were able to find one object that hit the Earth's atmosphere that was consistent with having come from another solar system, they did some math and some stats, and they made a lot of assumptions that were all based on scientific observations as best we know. But there's lots of wiggle room in this. But based on the values that they used, they were able to estimate. And here I'm reading from an article from Science News. Loeb and Suraj estimate that Earth could be struck by one, and this is an alien asteroid that they're talking about, one of these asteroids every 10 years. That would mean about 450 million interstellar meteors might have hit Earth across its roughly 4.5 billion year history. Now, while the 1 meter-ish object that hit us back in January of 2014 disintegrated in our atmosphere and was unable to deliver anything to the surface of the Earth, this kind of a frequency of bombardment of interstellar material indicates that life here might actually have started elsewhere. And that's kind of cool and kind of terrifying. And kind of awesome, and just makes me think of the old version of Battlestar Galactica. This tells us that that original idea of panspermia, that life in one world can be carried to another, just might be possible. But it requires a lot of special things to happen. For instance, if we wanted to have life here on Earth get carried to another world, we'd have to have an earth-shattering event occur, at least for small values of earth shatter. Literally, you need to have something occur that flings rocks carrying life off of the surface of our planet at escape velocities. This is what happened when the dinosaurs were killed. It is possible that bits and pieces of our own world, complete with life, were shot off of our planet at velocities that weren't just escape velocities for our world, but were perhaps even escape velocities for our solar system. We don't know. We weren't here, but it's an intriguing possibility. And this also means that life here might not have originated here. And this starts to get to it's turtles all the way down, because if there's always well, life here could have started out there somewhere argument, well, where was the first place life originated? Is all life related? Are we going to keep finding, well, the same DNA tree wherever we go? If it is hard to form life, is it easy to scatter it? This starts to get into questions that touch on philosophy, religion, and so many other things that probably require late night conversations with friends, rather than a discussion on a science news show over lunch. But hey, I now gave you things to talk about over your weekend. Okay, in more news of alien asteroids influencing other solar systems, we have, in this case, an interesting tale coming to us from Suzanne Falsner and Michael Bannister, respectively of the Max Planck Institute and Queen's University of Belfast. The two of them were at a conference together and got to talking over breakfast about an intriguing idea. Well, we've thought about the consequences of something like Oumuamua coming in and perhaps killing life on Earth as it invades our already formed solar system. What would have happened if instead something like Oumuamua invaded a still forming solar system? Part of the way that planets build up is you have a disk of material, and within that disk, you'll end up with collisions of stuff forming bigger and bigger and bigger stuff. This is sort of like if you leave your sugar alone on the counter over time, chemical reactions will cause bigger and bigger lumps of sugar to form. Well, gravity will form bigger and bigger lumps of stuff to form in a forming solar system. Now, as things get bigger and bigger, their gravity gets bigger and bigger, and they're able to attract more and more stuff from farther and further away. Now, what if instead of waiting for the collisions to take place of their own accord, you instead fling already fairly large objects into a forming solar system from somewhere else? What if Oumuamua, a fairly significantly sized asteroid, had entered a still forming solar system with just the right velocity to stay? Oumuamua was going way too fast to get captured by our sun, but it's conceivable, and in fact, we see one, for an asteroid to come in and get captured. Recently, we talked about how there's evidence of an asteroid out not too far from Jupiter that is orbiting in the wrong direction, with the wrong physical properties to have started where it is now. It is thought that this is an object we might have captured from another solar system. Now, there's other ways that, with a great deal of violence, it could have gotten there. But if we see one possibility, that helps us think, well, maybe there's more. When we see one Oumuamua, it helps us think maybe there's more. We see the 2014 collision, and it makes us think maybe there's more. And if you take one of these rocks from another solar system and throw them into a forming solar system, they could form the seeds of new planets. So it could be that at the heart of some worlds, there is stuff from somewhere else that got cannibalized and turned into the start of a planet. This works a lot the same way some chemistry projects that you might have done with your kids or might have done yourself start out. You can, for instance, make a really high sugar concentration mixture by mixing water and sugar and boiling it. And if you put a stick that you have coated in sugar crystals into that solution and suspend it there somehow, it will grow a sugar rock candy lollipop onto that popsicle stick. And what you're doing is you're seeding the crystal formation with those already existing sugar crystals that then attract in all of the sugar suspended in the water. That's a chemical process. Well, it's possible that gravitationally you can have seeding done by rocks from other solar systems. More cool things to think about. There is a lot of philosophical implications for the discussions of the science news we have today. There's going to be a lot of talking over the weekend going on. Okay, in one final, not philosophical at all, bit of news. In the middle of this very white image, there is a disk of stuff and things, and that stuff and things is Mars 2020 getting assembled for launch out at NASA's Jet Propulsion Lab at Caltech. This is High Bay 1, a clean room in JPL's space assembly facility, and this is just an image showing, hey, they're doing everything they can to be ready for launch in July 2020. So here is wishing you the best. This is a mission that has periodically been a bit behind schedule, and when you have a launch window, that's a bit terrifying and worrisome. But progress is being made. So go team, go. We have all faith in you. And that concludes today's news, and I will take your questions. While you type them in, I'm going to remind you to please at CosmoQuestX. Now, that I'll answer your questions is for the people who are watching live right here on Twitch TV. And for those of you who are watching us on YouTube, well, first of all, Thank you for watching us on YouTube, and please subscribe to our channel. I am seeing your comments, and I really appreciate all your warm thoughts. There's been a lot of really good questions coming in, and not questions, there's been a lot of really good feedback coming in. And every time I see names like Zap Fan over again, it's just nice to know there's a community out there watching. So thank you, and we see you, and we appreciate that you're there. Now, this is a production of the Planetary Science Institute working in collaboration with Youngstown State University. We bring you the Daily Space live on twitch.tv/CosmoQuestX every Monday through Friday at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. We also have the Sunday Science Hour with Annie Wilson. Same time, same place. Join in and watch as she transforms Hubble Space Telescope images that come down in black and white into the beautiful color images you've come to come to expect. Now, we are here thanks to you. We are supported by you, and it is, sorry, I'm having a software problem here. It just worked. Let me see if I can resurrect. I'm so sorry. Occasionally my screen is just like, no, I won't function. I won't. We are currently using a trial version of Okay, we are currently using a trial version of Wirecast, and our trial version periodically is just like, no, you can't. I won't let you. Nope, can't do it. And it looks like we were having one of those moments. Okay, so we are here supported by you. We are so grateful for everything that you give that allows us to keep going. I've had a lot of people asking what is the best way to help the show, and the best way you can help is either to sub over here on twitch.tv, and you know what to do that, or go ahead and follow us as a patron on patreon.com/CosmoQuestX. Both your subs on Twitch and your Patreon subscriptions allow us to, well, count on your money to help us make the bills month after month. It is your sustained efforts that allow us to sustain this show. Now, if you can't help out, that's okay. With my job changes and our funding changes that hit in December, a lot of people whose art I really appreciate, I just can't support at the level I'd like to. I get it. But please just be here to learn. It's this community we have that really matters the most. I love dropping in to Discord and seeing all the conversations going on, and the fact that we have this community of people who work in space science, who work in geology, who work in art, who work in just about everything, all sharing ideas and building, well, building knowledge together. So thank you all for being part of everything we do. Okay, I am now going to scan through the chat and see what all I can find. And once again, the software that I was using, for those of you who are asking, it is, did I lie about its name? It is Wirecast. We are still using a trial version. I love this software, but periodically it's like, nope, this is a trial version. We're going to eat what you're trying to do. It costs like $600, and I haven't sucked it up to buy it yet. Okay, here we go. Here I try and go. It doesn't want to let me scroll. There we go. Okay. Starting at the top. Oh, I see all of you trying to tell me I have no audio. I'm so sorry. I had the chat buried. I'm sorry. Thank you, Susie, for text messaging me. Susie, you are the best. Okay, got fixed. And I'm going to work on the POW, figuring out how to lower the audio. Sorry about that. Um, Thank you once again, Wayne, for your sub. I owe you happy Cheerios for the doggos. Eddie. Okay. Sleepy dogs shall enjoy Cheerios very lazily. I may have the laziest dogs ever. Okay, there we go. Thank you, Wayne. We thank people around here the best way I know, which is to provide cuteness, thus throwing Cheerios at dogs. So Astro YYZ comments, regarding fault quakes in California, can you compare frequency of these to other areas not on fault lines, i.e., are there every 3 minutes? But what would be average in a non-active locale? In a non-active locale, it would be more like you don't detect anything that isn't directly directly attributed to something like fracking, mining, gas lines exploding. All those things show up on seismographs as well. And this is where quiet areas are actually quiet at the level that was monitored by this particular set of experiments, but they're quiet in terms of the Earth not causing shaking. With the once every 3 minutes, that is geophysically related, as opposed to fracking, mining, exploding, all those kinds of things that you can also attribute. Now, one of the things that's interesting is there are geologically active areas that aren't on fault lines. I for one, have the misfortune of living on a pucker plate. So where we are, with the San Madres, they call it a fault, but okay, let me rephrase that. There are faults that aren't affiliated with plate sliding. The fault line that's near where I am, that has had massive, like magnitude 9 earthquakes in the past, is related to the plate puckering and shifting over time. Various papers I've read have attributed it to everything from the plate slowly readjusting to no longer having glaciers on it, which it did hundreds, thousands of years ago, to just general pressure building up on the plate. So this is more like what happens when you stick a cookie pan in the oven and it fluxes. Well, where I live, the ground is flexing. So you have lots of different things that can be detected on seismographs, and quiet is a matter of quiet according to what measure. So there are places that are geophysically quiet due to the plates not moving, but you may have other sources. So how busy your plate is all depends on humans and geology. Fracking is actually kind of making a mess of seismography in Oklahoma because it is triggering a lot of low-level earthquakes. Thor, God of Thunder. Yes. Yes. Okay, scrolling. I love how you're discussing laser shows. I miss being able to quickly go to laser shows because I lived near a museum. Yes, Wolf Caller, this is a newscast. Did Wolf Caller ask a question that I didn't answer? Wait, is this a newscast? Yes, this is a newscast. Now I see. Okay, Ref's Mask says it's the proto-molecule, no doubt about it. I assume that you're referring to a asteroid seeding a solar system forming planets. Because I go back to read the chat. Sometimes I need a little bit more context. So Larry Weird and Proud asks, how does the modern theory of solar system formation differ from Laplace's nebular hypothesis? Big picture, they're the same. The modern one has filled in details. That's the big thing, is we now have a timeline. We now have the age of heavy bombardment. But the grand idea of a solar nebula gravitationally collapsing and spinning up and seeding planets throughout the disk, all of that big picture is the same. Fenrig asks, what kind of mechanism could enable asteroid capture without destroying it? It's just a matter of something having the right velocity when it wanders near another gravitational object. This has actually happened in our solar system with other solar system objects. We look at Mars and we think that its two moons, Deimos and Phobos, are both gravitationally grabbed onto asteroids that were brought into orbit. In that kind of a scenario, you have a world and you have an asteroid. And your asteroid is happily flying through the solar system, and it's on its happy little orbit, and it just happens to intersect the planet Mars just right so that Mars changes its orbit. And it'll start out in a highly elliptical orbit, but tidal forces, interactions with other objects will generally circulate these orbits over the billions of years that our solar system has been around. We also see Triton going around Neptune or Uranus. I'm having a moment of not remembering which world Triton is going around. I think it's Neptune. And Triton, we believe, is a Kuiper Belt object that was stolen from the Kuiper Belt and turned into a moon. It's just a matter of matching orbital velocities quite accidentally. If you have something that is on an elliptical orbit and something that's on a round orbit, the periods are going to be different, and eventually they may hit up to being in the same place at the same time. And if they just miss at just the right velocity, you can get a new moon. This is part of why studying near-Earth objects is so exciting, because they have the potential to not just become a new moon, but also hit us. And yeah, that's a thing. Okay, scrolling. Yes, Larry, Weird and Pound. There are some big clean rooms out there that they build spacecraft in. So the command prompt is asking, what is the link for the Lightning YouTube video? One moment and I will find it. And we do work to get all of this put up on YouTube with links to the original stories. Yesterday, I was a bad human and didn't get Susie, who does the production for us, all of the links. They now have them. But in general, you can catch by looking at the show notes on YouTube, you can get links to every story we do. Okay. Did I not show you the dogs before? I have a feeling that I forgot to show you the dogs in transition. So here's more Cheerios for the dogs in case I screwed up. Okay. D7V1D asks, if all the ice melted in both poles, how much damage would it do? We would lose like Louisiana, Florida, chunks of Italy. Pretty much low-lying coastline would be gone. Cities like Boston and New York would be devastated. We don't want to try that. It's a fairly significant percentage of the Earth's population lives within a few meters of sea level. And so when you get those few meters of sea level rise, which are caused through a combination of when the sea ice melts. Thank you for the bits. Who am I thanking? Thank you, Fenring, for the bits. Yay, bits. So when sea ice and snow and tundra melt, there's two different effects. The first direct effect is the water that had been tied up in ice on land goes into the ocean, and that is responsible for some sea level rise. The other problem that you have is ice cover on top of oceans, ice cover on top of land, all of this white shiny stuff. When it stops being white and shiny, the light that it used to reflect upwards is now instead getting absorbed into the liquid ocean and into the soil, and that increases the temperature of the planet, and that increase in temperature causes water in the oceans to expand. It's actually the expansion of water due to the rising temperatures of the world that is literally the real killer. It changes where different critters are able to live. It changes, well, coral reefs die off. And the expanding seawater is actually causing the sea level to rise at a faster rate than simply dumping water in, according to papers that I read recently. Yeah. So Jay Serrara says, I recently listened to Astronomy Cast episode Water, Water Everywhere, and you commented on the absence of water on or in Venus. I know it rains sulfuric acid, but it was my understanding that acid necessarily has water as part of its solution. Does that conflict with no water on Venus, or am I missing something? So to make acid, you need water. To have acid, you don't need water. So Venus, once upon a time, may have had H2O molecules. The components, the H2 and the O, in that water has since got tied up into the much more complex molecules that make sulfuric acid. Now, when we have a jar of sulfuric acid here on Earth, the jar we have is usually a solution. So you might say it's a 5% solution. You might say it's a 10 molar solution. Different units get used. In all of these different cases, what we have here on Earth is a mixture of water and acid. If you're on Venus, it's not a mixture, it's just acid. This is why spacecraft die. So you're not wrong based on what you learned in chemistry. Venus just likes to take things to extremes that we don't have here on Earth. Yeah. Thank you, Larry Proud. I still love you too. Thank you. Yes, Ref's Matt is correct. It's the New Madrid fault of 1811. It actually caused the Mississippi to slush in a way where it flowed backwards and jumped from one place to another. The Mississippi moved. Anytime an earthquake moves the Mississippi, it's a thing. It's a thing. Yeah, Texas had a plate buckle near the Rio Grande. I too, Jandraloon, am a fan of earthquakes. I'm more of a fan of volcanoes. I sometimes think that if I knew you could go into comparative volcanology as a career, I might have gotten a different college degree. Okay. Okay, so I'm glad that you like my explanation. And I've hit the bottom, and I have a dog right here. Come here, Eddie. So I'm going to let him hop up on camera. Come on up. So this is my trusted bud who deeply appreciates all of you do to support the show. And his groomer groomed him specifically to make him look as much like a teddy bear as possible. And he's now like, I see the entire container of Cheerios. Can I have it? No, you can't. Here. I'm going to throw them. Go. There. Okay. My food hound is food hounding. Yeah, Stella's very lazy when it comes to food. She's never missed a meal in her life. Eddie, when I found him, was half the weight he was supposed to be because he'd been starved. So that was a lot of news. That was a whole lot of news. Not all of it good, but all of it good in terms of we're advancing our understanding. And it's only through understanding things. Thank you, Herleu. Thank you so much, Bloombaldi. Yay. Thank you. So it's only through science that we understand what's going on in the world around us. And there's a line from the musical Into the Woods. It's nice to know a lot and a little bit not. And I think that sums up today's news. It's nice to know a lot, but a little bit not, because, yeah, yeah. Well, Eddie wasn't. He doesn't have a docked tail. Eddie actually, because of his breed has been bred to have less and less and less tail. There's no scar. There'd be a scar if it had been docked. He just has no tail. Australian shepherds, like him, have been bred to look as much like sheep as possible. Stella, which is also an Australian Shepherd, has a nubby of a tail because she's a bit of a genetic defect. And that's okay. I still love her. There, you can see the little tail walking through the screen. Um, okay, we're now off topic. Thank you for being here. Please consider supporting us on Patreon. It really helps us make ends meet. The show that you're seeing, a lot goes into making it. Susie posts it up on YouTube every day and puts together show notes. We have Annie, who produces a lot of the rocket launches that we cover. And I just want to pay people what they're worth. So help us do that. And all of your bits help too. And here is a dose of cuteness, a little bit closer to the camera, as thanks. So this has been a production of CosmoQuest. We are your place to learn and do science. We are created out of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploration of our solar system. Please check out everything we do, and thank you again for everything you do. We are here because of you, and we are so grateful for how you've helped us out. Now, I am going to raid somebody. I haven't figured out who yet. So if you have any suggestions, please drop them into the chat now. The place that I go to look for people to raid is the Knowledge Fellowship. Okay, so that's me. Oh, Bother is streaming. So we are going to raid, unless I see any other suggestions. Oh, Bother. Oh, Larry, that is such a sweet and awesome statement. Okay, so we're going to raid Oh, Bother, and have a great morning, evening, afternoon, wherever you may be in the world, and get outside and look up.